All right, let's take care of this week 4, College Board Unit week 4, Unit 4. And so here we go. So this first question is 2019 question number 5, I believe. So 2019 question number 5, where you were first asked to, you had this information about the smartphone and people were buying a insurance on it for $50. And so we wanted to see if the proportion of people who were going to actually have to get the phone replaced and so on and so forth. So what we found was that the average length of the lifespan of the battery was 30 months and a standard deviation of 8. And so then that price for the insurance was $50. So we were first asked what, in how many months from the date of purchase is expected that 25% of the batteries will no longer work. So you had to get that lowest 25% of times. And so the mean was 30 and the standard deviation was 8. I should have probably put at least one number in here with the 38. Okay, so that you could see that on the picture. But I can see that this is the area I'm looking for that lowest 25%. And so we wanted to know what that value was right there for the lowest 25%. In order to do that, you had to get the z-score right there. And so I inverse normed 0.25, that lowest 25%, and I got negative 0.67. And so then I set up my x minus the mean over the standard deviation formula, and I got that there to solve for 24.64 months. Now, credit-wise, you had to indicate the use of the normal model with a mean of 30 and a standard deviation of 8. So the ways you could do that is graphically. You also could do that for the z-score if you showed this z-score formula filled out with the actual z filled put in there. So I had said z equals this number. And then I put that number over here. So I am indicating z. That implies the normal model. If you don't have z written anywhere, then you're going to lose credit for not indicating the normal model. That's why a picture is the best way to cover your bases on that. All right, and then setting up that process correctly. By the way, if you used incorrect notation on the first part by putting x bar equals 30, that's a sample mean. That's not a sample. This mu is the mean of the population, and that's what we had. And if you use little s equals 8 instead of sigma equals 8, then that's a problem. You're supposed to have the mean is 8 and the sigma, or mean is 30 and the sigma is 8. All right, and so then the third part was that correct 24.6 months. You did not have to write the sentence. So if you got all 3 of those correct, you got an E. Only 2 correct, you got a P. The second part said, okay, suppose one customer purchases it, and what is the probability that that customer will be required to replace within 24 months from the date of purchase? So that means so I'm setting up again this normal model with a mean of 30 and a standard deviation of 8. X is 24. That's what they were wondering about. And I have to show this shaded area below 24. So anybody that had 24 months or less, let's see what indicated that had, will be replaced within 24 months from the date of purchase. So 24 months or less. So I indicated so same way of indicating normal model you had to do. So I indicated this normal model with a mean of 30 and a standard deviation of 8 by drawing a picture. You had to indicate, okay, so that was first thing. You had to indicate, second thing is this boundary of 24. You could do that also by having this here in this formula over here, the z-score formula. So that indicates a boundary of 24. So once you get that z-score, then you have to indicate shaded area. This calculator speak does not indicate shaded area or the direction that you are getting the area for. You had to show this shaded area, or you had to say something like the probability that x is less than 24 equals that number. So those are the ways that you get credit for indicating direction. So what we have here is showed the normal model, indicated that boundary of 24 and the direction, and then did the correct math and got the correct percentage. So the probability was 0.2266 or 22.66%. So I expect that's the percent of people that will have to take advantage of that $50 of that insurance. Okay. Now, the third part said, okay, so what's going on with the costs for the for how much money is the company making? Okay, so they know that they will gain $50 for all the customers who purchase the insurance but don't require it. Then they will lose $150 for all of those ones who ended up having to purchase. So for all those who had a battery go out. So what that means is this right here. The proportion of people who will of times that they will lose 150 is 22.66%. So whatever was number you got in part B, they wanted to see that carried down to this part C. So if you had gotten something wrong in part B, but then you carried it down properly into part C, you could still get full credit. And so then the other part of the time, so if we're thinking about it, this percent of the time they lose $150. This percent of the time the company gains $50. Okay, and so over here they lose $150. So we could represent that by this expected value. So that percent of the time I lose 150. This percent of the time I gain 50. So on average, they will gain $4.68 for every warranty that is purchased. Okay, so that they want people to purchase this thing because on average, that's what's happening. All right, so let's see how you did. You had to base your probability on the sum, and you could use an incorrect value carried over from part B, and you got something 4.68, or the correct value carried on from part B. Did you get both of those correct? You got an E. So take a look at how you did. If you got all correct, you got a 4, 1 partial, you got a 3. Here's several different ways to get a 2, and then here's how you could get a 1. All right, moving on. So for this next one, we're going to have probabilities. And so we have here the probabilities. Let's see what we got going on here. Okay, so first, what's the probability that a person selected will be someone whose response is never and who is a woman? So that is the intersection. So out of all of the people, so out of 100%, who were never and a woman. And so that is the only problem. Part 1 was the only one where you did not require work to be shown. You could just put the answer 0.0636. Now, the next question needed work shown. What's the probability that the person selected will be someone whose response is never or who is a woman? So then if we're talking about that section here, then what we want is these parts that are the woman and also that part that is never. So you could show the work of adding those 4 numbers up. Okay, the other way that it could happen, and this comes from the formula chart, which I don't have handy to show you that, but coming from the formula chart, that comes from the probability of A plus the probability of B minus the overlap. And so I want to demonstrate that to you here. So probability of A, 0.53, plus the probability of B, 0.12. But if I add together 0.53 plus 0.12, then you can see this piece right here of never women got double counted. So then that's why we have to take that away. So we can add their totals and then take away the part that got double counted. That's another way of showing your work on here. That's what I did take the total, subtract the part that got double counted, and then there you go. Okay, so the way to get credit on that part 2 there was show work and get the correct answer. Number 3, this was a conditional. It was given that you are a woman. So out of the 53% that are women, what proportion of the women said never? So you had the intersection, and this also is on the formula chart, that probability of A given B. So it's written on here, probability of A given B is probability of A and B, so never and women, over that probability of B. So then that's how that came. And to get credit on this, you had to get the right answer of 0.12, and then you had to show the numerator, correct numerator, and the denominator. So show those credits. Okay, so let's take a look at that and see how you did. So you had the correct work. Here, work must be shown to get credit, or you do not get credit. You had to show things you added and subtracted together. And here, you had to show the numerator and the denominator to get credit for that. Okay, next question. After it walked you through those 3 parts, then it said, are responding never and women independent events? Okay, so this is one of the things that, the fact that you are one thing does not change the rate. So that would mean if we saw the probability of never overall, and we would compare that to given that you are a woman, does that change the probability of never? You choosing never. So we would want to see, is the fact that you are given that you're a woman, does that change the probability of you being never? And those numbers actually come straight from up here. Overall, the probability of choosing never is 12%. We can see that right here from the chart up above. Overall, probability of choosing never. And then if we do, given that you're a woman, the probability of choosing never, then never and woman over the women. So that is actually like just what you did in part C. So that's, or part 3 right here. So we compare this to this, and we can see that those are the same. So the fact that you're a woman did not change the probability of you choosing never. So never and women are independent events. So here's how you get credit for that. You said, yes, they are independent. Okay, and then here are options of how you could mathematically or statistically indicate that. And so here we had this thing where never given that woman and woman given never, those kinds of, either one of those are the same as their counterpart. This is the one that was most common and should be. It makes the most sense. The fact that you're a woman does not change the probability that you're going to choose never. Okay? So setting up one of those mathematical methods. And then with your justification and explained, that you had to do that explaining that the fact that you're a woman doesn't change the probability of you choosing never. So explanation, those 3 things. So would you have gotten credit on all 3 of those? Would you have just done the math? Let's see. Partial credit could be if you explained it properly. However, one event does not, and you said one event doesn't affect the other, but you failed to provide the proper mathematical support. That kind of thing. All right. And then our last piece was a binomial component. So let's take a look at that. So they said out of 5 randomly chosen women, what's the probability that at least, out of 5, what's the probability that at least 4 of them will always take their medicine properly? So that's 5, choose exactly 4, and then plus 5 and exact all of them. So 5 choose 4 and 5 choose 5. So this is a binomial situation because it's not a continuous where we can have like partial amounts of people. 4.3 people choose it correctly. No, it's 4 choose it correctly or 5 choose it correctly. So I want to do binomial PDF of 4 correctly plus binomial PDF of 5 correctly. The alternative would be 1 minus the binomial CDF and take away the bottom 3. 1 minus the accumulation of the bottom 3. So that, well, 0, 1, 2, and 3. That would leave me with 4 and 5 left. All right, so first, the probability of always was 0.54. And they needed you to somehow state that show that it was binomial. By doing this formula here, it indicates, by doing the formula that I have written here, it indicates binomial because I show the binomial formula. And it's a standard formula, so that counts. I also indicate that n is 5 by putting 5 right here. Okay, and I also indicate that the probability of success is 0.54 because I did that here, and I also did that right here. Okay, so those things are what is going to get me credit for indicating binomial and indicating what n is and indicating what probability of success is. Okay, so let's go through those here. Indicated binomial with a n of 5 and a probability of 54.54. Then I also did the formula. So I did that. And so correct boundary and direction. So 4 and above. Okay. But what's interesting is I wanted to show you all these ways that you can get credit, and then of course the correct probability, okay? But I wanted to show you all these ways that you could actually get credit and not have to have written out the binomial formula. If you did 1 minus binomial CDF and you identified n equals 5, p equals 0.54, and the upper bound equals 0.3, and that equals 0.24, that actually gives you full credit of an E because that indicates binomial. It tells you that n is 5, p is 0.54, and that the upper bound was 3. Now, look at something like this one right here. The second, ooh, that was not good. So look at this second piece right here. This says 1 minus binomial CDF, n is 5, p is 0.54, and then they just say 3. So they didn't indicate that that was the upper bound. So they lost not indicating the bound. So that's a p. All right. If you just wrote this calculator speak, 1 minus binomial CDF, and you didn't put identify any of those parameters, you didn't get credit. Okay, so you knew how to mathematically do it, but then you didn't get credit. All right, so see how you would have done on all of these, and that, EEP or whatever, and then you can see down at the very bottom how you would have gotten your 4, 3, 2, or your 1. All right, so I hope that helped you. I hope that kind of brought back some memory of how to do those binomial problems and what you have to show for that. And so good luck to you on next week's Free Response Flex Fridays.